This video is supposed to give an overview about the different existing Cubase algorithms for audio material. Algorithms matter when the sound is manipulated either by tonal shifting or time stretch or both. The difference between algorithms is how they react on the time stretch and pitch shifting effects. If the sound is not altered at all, it doesn't really matter which algorithm is used. Here's an overview about what we are going to look at in this video. Use the timestamps to navigate to the chapters. Audio using the tape algorithm will adapt to speed changes. When I activate the tempo track, the sample will speed up or slow down following the speed of the project. The same thing happens when I stretch the audio using the time stretch tool. Audio using the tape algorithm can also not be transposed, no matter how hard I try. Only when I switch to another algorithm, I'm able to transpose the audio again. Now we are looking at the Formant algorithm, which preserves the format when transposing audio. To illustrate the difference, I'm going to play the same sample pitched up a few semitones in the élastique format pitch and in the normal élastique pitch algorithm.
What dimension am I in? What dimension am I in?
As you can hear, in both cases the audio gets transposed, but the standard élastique algorithm has a much stronger pitch effect, while the Formant pitch sounds as if the singer would just try to sing higher notes.
What dimension am I in? What dimension am I in?
Okay, now we're trying to find out the difference between the élastique efficient and élastique pro by heavily stretching and pitch shifting two versions of the same sample, one using the efficient and the other one using the pro algorithm. Let's listen to the difference at this position. I could not hear any particular difference in quality. What happens if, in addition to the time stretch, we also heavily pitch shift the audio? Again, no difference. What about another sample location? I personally could not hear any real difference between efficient and pro. Let me know in the comments if you noticed anything. What is the difference between elastic time and elastic pitch? To find out, I took another sample and converted one to elastic time and the other one to elastic pitch before heavily time stretching both samples equally. Let's compare the results. I noticed a small difference at the start of the sound. The time sample sounds a bit more stretched at the beginning transient compared to the pitch sample. What happens if we also pitch shift both samples? From the differences at the beginning transient of the sample, I could not find any other differences between elastic pitch and time. Is there a difference between Elastic Pro and the standard algorithm? To find out, I took a sample and again heavily time stretched one version using the elastic time and the other one using the standard mix algorithm. I think the difference is quite obvious. There is an audible stutter effect going on when we listen to the sample in the standard format. The elastic version sounds much smoother in my opinion. Okay, we are now going to listen to the same sample in Elastic Pro and in standard mix format, but this time heavily pitched and not time stretched at all. The difference is again very noticeable. The elastic algorithm produces a much smoother result, without any stuttering. Let's now compare how all the different standard algorithms behave when applied to a stretched sample. This gives us an idea about what their different approach is. Lastly, I would like to make you aware of the limits of the standard solo algorithm and how to get around that. We are going to use this vocal sample as an example.
I started losing sight my play.
The standard solo algorithm gets automatically activated as soon as we start to do any pitch shifting in Vari Audio. As you can see, the algorithm switched to standard solo. When we now transpose the audio in some way, the audio will shift in pitch, but in my opinion, the standard solo algorithm does not the best job here.
I started losing sight my place.
Another algorithm will perhaps produce better results, but we can't simply change the algorithm in this case, because this would undo all the careful vocal tuning that we did previously in Vari Audio. This is why we need to make our changes permanent first. We can achieve this by bouncing our vocal sample. Now we can choose different algorithms again without losing our Vari Audio editings. Here is what the Elastic Pro algorithm sounds like compared to the standard solo algorithm.
I started losing sight my play.
I started losing sight my place.
I think in most cases the Elastic Pro version will be the preferred option. Conclusion. The tape algorithm adapts to the replay speed of the sample. If there's a difference between Elastic Pro and Elastic Efficient, it's very small and I couldn't notice it. The Formant algorithm aims to preserve the sample's format when transposed. When comparing elastic time versus elastic pitch, you can notice a small difference at the beginning transient of a sample. When comparing the elastic versus standard algorithms, you can notice that the standard algorithms stutter much more when pitched or stretched. When using Vari Audio, you should bounce the edited audio to get rid of the standard solo algorithm, which is, compared to the other ones, not that great sounding. I have created an overview over the Cubase algorithms in this table, which you can download for free using the link in the description. Also check out the official Cubase manual to learn more about algorithms.